BCDE is a square, and the lengths here are given to us. We are asked for the area of triangle ABC. Let's get started. Now, the first thing that catches my attention is that after writing the angles of this right triangle here, so after calling this one alpha and this one beta, I encountered the following situation. Since alpha and beta are complementary angles, that is, they add up to 90 degrees, the small angle here, since the whole thing is 90 degrees, becomes the alpha angle. And I want to continue following this clue here. So, if I construct the right triangle here as well, let's extend the line segment AB and drop a perpendicular from C to it. Since I have formed a right triangle here as well, if I call this angle alpha, for the same reason, I have to call the other angle of this right triangle beta. Now, since the angles of this constructed triangle are equal to those of the original right triangle, I can say that they are similar triangles. In fact, since the hypotenuse here, that is the segment EB, and the hypotenuse of the triangle I constructed, that is the segment BC, are of equal length, these are congruent triangles. This means that if alpha here faces 12, then alpha will also face 12 here. If beta faces 30 here, then beta will also face 30 here. Let's show that as well. Now we can solve our question. Let's make a reminder about the 3, 4, 5 triangle. Actually, multiples of the 3, 4, 5 triangle that we see in right triangles are also possible. That is, a 6, 8, 10 triangle can also be the size of a right triangle. Let's take 3 times the values. A 9, 12, 15 triangle can also be the size of a right triangle. I see a situation here. This side is 12 and this side is 15. Look, so what will my other side be? It will be 9. Now, here I add 12 and 9, 21. I subtract it from 30, and thus, I find the length of the short line segment here. This part will also be 9. Now, if I take the AB line segment here as the base of the triangle, its length is 21. The height corresponding to this base is the perpendicular line segment I drew here. That is 12. Using base times height divided by 2, I calculate the area of the triangle as 126 square centimeters. It was a very elegant question. In my first solution, I didn't solve the question this way. In fact, let me show you how I solved it. I went and constructed the exact same triangle here. I also labeled this angle here as alpha. That's how I did it, and so on. That's how I figured it out the first time I solved it. But after doing it this way made a lot of sense to me. But of course, since this solution is much more classy, I shared this one with you. If you also come across such nice geometry questions, don't forget to share them with me, because I have a great time solving these questions. In fact, there's someone else like me. Let's briefly talk about him as well. I first came across the idea of enjoying solving geometry problems in a book I read at university. Everyone always knows and talks about Aldous Huxley's Brave New World or George Orwell's 1984. But there is also a writer named Yevgeny Zamyatin, a Russian author. It must have been in the early 20th century. He has a book called We. I think it means we. In that book, there was a protagonist, and that protagonist used to solve geometry problems in his spare time. Just like that. I also really enjoy solving geometry problems in my free time. Let me mention one more detail. It's a book that was written a very long time ago. At the same time, in the world where the story takes place, robots could make music. Isn't that a great prediction? See you soon.